Hello again. We are back to the fourth part of our afternoon session, New Added Value through Key Components. And as we saw in the clip today, now it's time for Fuel Cell On. And for this, we have an excellent expert here. We say a warm welcome to Professor Dr. Markus Hölzle. He is member of the board and head of the Electrochemical Energy Technologies Division at the Center for Solar Energy and Fuel Cell Research here in Baden-Württemberg, short form CCSW. So, Professor Hölzle, it's so good to have you here. The stage is yours. We are looking forward to your presentation.
Yeah,
thank you.
Thank you very much for a great introduction. It's a pleasure being here and basically to terminate the day today with a lecture on fuel cells. And as you can see, I am a member of the board of the CCSW and I'm responsible for the activities within the CCSW for batteries and fuel cells. And we come to some details later in the presentation. The talk is about HyFab. It's a new endeavor that we are running together with partners, really to accompany basically the launch of fuel cells in the mass market. And you will see what we are planning to do and also what we are planning not to do, because that is as important as what we really want to do there. But before going in, let me introduce the CCSW, because it may not be known to all of you. The CCSW is an institute with roughly 300 employees, among that 250 scientists, and an annual turnover of 50 million euros, what is quite a high number because we are really running big size equipment. And the specialty of our institute is that we are really cooperating very close to industry. Our base load funding from the state of Baden-Württemberg is rather low, and therefore we have to bring in a lot of money, both from R&D project, but especially from industry. Our focus is on batteries and supercapacitors, hydrogen and fuel cells, on photovoltaics, on renewable energy fuels, and also on energy politics and economics, as well as our newest baby on wind energy. If you see all the long list, you may put this together in a way that we really take care for the primary energy generation as well as primary energy conversion and storage. These all are very hot topics today, and they are topics that are changing the way we are living. And therefore, I think it's good that CCSW is taking care for these topics for already 30 years in a row, and therefore we have a great experience dealing and delivering great results. I mentioned already that we are dealing with many companies, professional companies in the field of batteries and fuel cells. A short list is shown here, and you may be among these companies, and the list is ever growing because this is the DNA of CCSW in difference to other institutes and universities, that our home turf is really to play with industry, because the mission of CCSW is to bring technology from university level into the market, and this is what we are doing on a daily basis. The CCSW, as I mentioned, is an institute founded by the state of Baden-Württemberg. Therefore, by definition, our sites are within Baden-Württemberg. Our headquarters is in Stuttgart, that you can see on the upper left-hand side. It holds our research on photovoltaics, energy politics, energy carriers, and our central divisions. We have a test platform for solar panels on the Schwäbische Alb, and we have two locations in Ulm. Ulm is at the border to Bavaria and is southeast of Baden-Württemberg, where we are running. On the upper end, you see basically our initial building, the building we had been grown, the CCSW, dealing today with hydrogen and fuel cells. And then the right-hand side at the bottom, you see the so-called E-Lab, where we are running our battery activities. Ulm is a rather small city, maybe 120,000 population, the bigger area 200,000. So you may consider Ulm as being too small for the topics we are dealing with, but that's not true, because Ulm is really one of the global centers of electrochemistry. Within the Ulm Science Park, we have 4 institutes dealing with electrochemistry. That's the University of Ulm, with a fundamental electrochemistry. That is the Helmholtz Institute, with a big focus on battery development and battery components design. We have the CCSW being responsible for technology development, prototyping, and transfer into the market. And we have the THU there, more dealing with the electronic part of the fuel cells, of batteries, of energy conversion and storage. This altogether is roughly 400 plus scientists dealing with electrochemical topics. And there are not so many centers of electrochemistry on a global basis compared to what we have available in Ulm, basically within a 10-minute walking distance. The CCSW, to come back to that, has 3 divisions. Basically, on the left-hand side, my colleague Fridtjof Steiß is heading the division for politics, for studies, for wind energy, but also for electrolysis. That means for hydrogen generation, for CO2 absorption, for e-fuels. Michael Powalla, who is managing our activities in photovoltaics, mainly dealing with thin layer photovoltaics. Today also with perovskite structures and other developments. And on the right-hand side, it's my responsibility in Ulm for batteries, hydrogen and fuel cells. In Ulm, we have roughly 180 scientists working on these 2 topics, so it's a rather big chunk of the ZSW. And again, you will see why we need so many people there, because we have a widespread development, both in batteries and fuel cells. What are we doing in fuel cells? Basically, we are doing everything from cradle to grave, but of course we have some certain focus areas because the system is so complex that nobody can really cover all the fuel cells in the whole wide span area. We are working on materials, for instance, electrocatalysts. We are not doing membrane development. We are typically buying membranes, but we're doing MEA. We're typically buying GTL. We have some development there. We are doing balance of plant components, but we're doing a lot in the stack design and stack construction, stack building, including a lot of modeling, design, and prototyping, as you will see later on. And with our newest baby, the HyFab, we also will move into the stack production that is lagging at the moment. We do battery production on a pilot scale, but we don't do stack production for fuel cells right now. We have a strong focus on evaluation. I think we are operating the largest independent fuel cell test field in Europe. We have roughly today 45 test benches where we are dealing with own developments, but also serving customers' needs and testing fuel cells from all the major players around in Germany. And we do a lot of analytics that you always need for the fresh products, intermediates, but also post-mortem. And we have a bunch of data, and a bunch means quite a lot of data from over 30 years of measuring fuel cells that we are now using together with machine learning routines for a kind of predictive lifetime and predictive maintenance development for fuel cells. We also have, and that's very important, in parallel, a lot of hydrogen activities. You only can operate fuel cells if you understand hydrogen. We have a lab that is called HyLab. It's also a trademark of BASF. It's one of the 3 leading hydrogen quality labs in the world. We just passed a global round robin test as number 1, 2, or 3. It wasn't basically disclosed at the end, but we had been among the top 3 out of 15 labs globally. And we also have a mobile test device for certifying hydrogen refueling station. It's basically a trailer that you see in the bottom center picture where we are trailing around whole Europe, and we're basically evaluating and checking the quality and the refueling standards of refueling stations. We also have a 700-bar refueling station on site where we can firsthand really monitor what's going on. And it gives you an idea that we are not just focusing on fuel cells, but also taking into account the whole hydrogen infrastructure. So let's now come to the HyFab project. The HyFab project is a joint endeavor of Fraunhofer ISE in Freiburg, of ZSW in Ulm, and the VDMA, what is a kind of association of the German mechanical engineers. And we all 3 together want to really accelerate the market launch of fuel cells. And you see the whole picture starts basically in dark winter, and it gives you some indication on a groundbreaking ceremony. This was indeed happening in Ulm in February this year. And you will see later on what happened really and what was happening in the meantime. But now let's focus on what is HyFab. HyFab should support the German industry in growing the fuel cell from something that is manufacture, that is handmade, into a mass product. We have a clear focus on the PEM fuel cell. We are not looking into other type of fuel cells. And we're looking mainly into the components, into the assembly, into end-of-line testing and the commissioning. We want to create and evaluate quality procedures and testing protocols as also standards. Most important, we want to generate an industry know-how. In Germany, we call it Branchenwissen. This is existing in the meantime for batteries, but it's not so much known what are the key criteria for fuel cells. What are people talking if they talk fuel cells? These are things we want to create and generate. It should be an entry platform for newcomers, especially for small and mid-sized enterprises who want to check if this could be a market and an industry they want to go in and what is really needed and necessary. We want to link and create new supply chains with new players, and we want to educate and train specialists, but also the general public. So that's the idea of the HyFab project. And it's a project that will also serve the industry with something we call generic stack, and I will show later on what is in behind that one. So basically, we want to give hardware to the industry and hardware to people and associations interested going into fuel cells, that they will really see what we have and where to go. It's very important we are not reinventing the wheel here, so we take what is available. We are not going into new catalysts. We are not going into new membranes. We will take the graphite-based bipolar plates and the metal-based bipolar plates. That's all available. And this all will make the way into the market. There's no need for reinvention, for new invention. That's very important. But there's a need to get these things and the tasks now done really quickly. And this is where basically the HyFab should support the industry. HyFab has received a lot of money from local and German governments, and I would like to thank the people who really organized that one, the ministries here in Baden-Württemberg of economy and of traffic and house building, and also in Germany, the Federal Ministry of Traffic. Altogether, there had been roughly 18.5 million euros flowing so far into this project, mainly for construction of new building and infrastructure. I showed you this later on, but also to our colleagues from ETH and Freiburg and to us to really start scientific and development projects to get things running. We are now looking into a future of 10 years and an additional funding of roughly 30 million euros coming from Federal Ministry of Transportation. And we are happy to receive so much money. On the other hand, we also recognize if you want to do reliable research and development at the interface between university and industry, you need a certain size of machinery, you need certain expensive equipment. You just have a need for such amount of money. But again, thank you very much for all the ministries supporting this endeavor. Why do we do this here in Baden-Württemberg? Because it's pretty clear Baden-Württemberg is the center of fuel cell development in Germany. And therefore, it takes a unique position in Germany. And it's maybe the role Baden-Württemberg will have to play in the next years if it comes to hydrogen development, hydrogen infrastructure, and hydrogen technology. We don't have all the wind turbines of the northern part of Germany. Therefore, many topics related to generation of hydrogen and storage of hydrogen will be explored in the northern part of Germany. Center part, North Rhine-Westphalia, taking care for use of hydrogen in steel industry, for instance, in chemical industry. But Baden-Württemberg is the heart of fuel cell development, with basically all main German players being a kind of along the highway A8 going from Mannheim here to Ulm. Companies like Audi, Cellcentric, Daimler Volvo joint venture, Freudenberg, ECPO, Elring-Klinger, Plastic Omnium joint venture, Iveco Magirus in Ulm for trucks, Robert Bosch for fuel cell systems. And if you extend a little bit to Bavaria, you end into Proton Motors, into smart fuel cells, into BMW, and again into Freudenberg. So that's all what you have in Germany, and this is all here. And you see Fraunhofer East in Freiburg and the ZSW in Ulm are nicely located in that center of gravity for fuel cells. And therefore, it makes a lot of sense to investigate here. Also, there is a lot of industry, tier 2, tier 3, tier 4. Right now, supplying the car industry here with Porsche, with Mercedes, with Audi, but also with Bosch and the other suppliers with parts and components. And these players also will have to transition into new applications. And this could be the fuel cells. And therefore, it's the right place to be here. That was identified. And therefore, we have everybody close around in a driving range of maybe 1 hour. And this is also very good to accelerate developments. The whole value chain that we are covering is basically starting from a membrane and catalyst. These are 2 components we are buying in. Then our colleagues in Freiburg from Fraunhofer East, you see it here in dark green, will take care for the CCM assembly and for the MEA assembly. And the MEA is then handed over to us in Ulm, and we will then basically build the stack, the fuel cell stack, out of the MEA and bipolar plates with balance of plant components. We will go into end-of-line quality check, and we will go into conditioning and commissioning of these stacks. So this is the kind of the burden sharing and work sharing that we have. And I think it's pretty nice because the core competency of Fraunhofer East for many, many years is on the MEA development, whereas in Ulm it's more on the stack development. You see a little bit the tasks that we have here, basically looking into the manufacturing processes and the process stability. What environment do we need? Do we need dry room? Do we need clean room? What level of clean room do we need? What is the quality check we have to do? End of line factory acceptance test. How much time do we have to do it? Right now it's a multi-hour testing, 8 to 10 hours. This has to come down to below 1 hour. These are all topics we are looking in. So there's a lot of work you can see here that will keep us busy over the next years. And again, all this will happen together with industry partners. The machinery that we will use will come from industry partners. It's not homemade, it's not self-invented. It's machinery that is used in the market and that we will take in our labs also to investigate the processes and basically to do that kind of work where the industry just doesn't have the time to take care for it, because industry is now in a rush to really bring this fuel cell from a handmade system into a mass production system. And there's so much work that has to run in parallel, and we will take care for part of this work in the HyFab project. Let's now focus on what's going on in the HyFab in Ulm. I mentioned already the groundbreaking in February, maybe the coldest day with a snowstorm that we had this year. However, what we see here is what we will get out of the groundbreaking within the next 12 months. It's basically a gas farm on the right-hand side to store all the necessary gases, especially hydrogen, of course. A big hall for testing of fuel cells, and a central building for offices and for basically all the technical systems that you need to provide all the electricity and gases and whatever and safety requirements for doing all the fuel cell testing. This building can hold at the end of the day roughly 70 test benches for fuel cells. And it's a picture from last week where you see the construction as it is right now. So the front part is the construction that is going on. It's still on the ground level, but now with this pre-manufactured pieces, we will see a big progress over the next weeks and months. You can follow on the ZSW homepage our live webcam to see what's going on. In behind are the buildings of the ZSW as they are today. The whole building complex, after being finished in 18 months, will look like that. We had been seeing the gas storage already. Just to give you an idea, up to 2.5 million norm cubic meters of hydrogen can be managed then per year. We have the testing hall there with 2 stories. We have the central building with the offices. And then on the left-hand side, we will see another construction starting most likely August, September this year. This is a real HyFab assembly hall. That's a building where the machinery will get into really manufacturing the fuel cells. And not shown here, but shown on the next picture is basically a building that is perpendicular on the left-hand side to the HyFab assembly hall. This is a building where we have a so-called Annex building. And this is where we will build in a big seminar area where we will do our training. You see it on the ground floor here. We have additional offices and lab on the first and second floor, directly connected to the manufacturing area, and again, directly connected to the testing area. So you see it's an impressive building complex that we will put there within 18 months. And this will allow really to give an environment that we need to really run this project full speed. I mentioned already one very important piece of this development is a so-called generic stack. And it's an open and modular stack design that ZSW has developed together with the VFF. It allows a stack power up to 150 kilowatt. It allows power densities up to 5 kilowatt per liter. Sorry, it's missing here the liter. It's an open source stack that we really can give out of our hands, that people can use without being limited by third-party patents. The stack is designed both with a metallic as well as a graphitic bipolar plate. And it's a seal-on-plate concept for the metallic bipolar plate. We have a full simulation of that stack available that we can share with basically our partners. And we have a digital twin under development. However, it's important that we are not focusing on a digital twin that maybe is a difference to many projects that we see today running in the university environment. We would like to have the hardware. We would like to be able to hand over 100 bipolar plates to a company that is, for instance, working right now already in forming metals, so that they can see what does it mean having a bipolar plate for fuel cells. We want to discuss with different companies being in the field of sealing technologies, because there are so many sealing technologies available, so we need a bipolar plate without a seal to test out different sealing technologies. That's all basically done with the hardware of the generic stack. and therefore we think it's very important to have it. The stack is, as I mentioned, fully designed. We had been already sourcing out some development packages to development partners. I can talk about the metallic bipolar plate with the sealant plate that is taken care by ECPO, by ElringKlinger. We have access to a graphitic bipolar plate that is not with a seal, so we are dealing with different sealing companies, but it also goes to like of the balance of plant components and the end plate components. So a lot of activity is going on there, and again important is to have something on hand that we can hand over to interesting companies that have so far never touched a fuel cell and never dealt with a fuel cell in their own development and manufacturing areas. The whole generic stack is based on the extensive expertise in simulation that we have at ZSW. So the flow field is really simulated in any detail from ZSW, knowing what is possible in the industry, but still in the final stage in close cooperation with an industry partner, because only industry can really give us the latest insights, what is possible, how thin can the bipolar plate become, how thin can the film become, what curvature is possible for the channels. But everything else is fully modeled, and we basically can hand over the modeling package also to other companies who are interested into entering, for instance, the field here of the metallic bipolar plates. So I think that's very important that you know that, because it's important that this is an open platform. There's no exclusivity in the HyFab. The HyFab basically can take orders from industry. There will be later on an industrial advisory board that will kind of take the orders, will discuss the orders, and then will release the interest and the orders from industry into the research and development organizations, both at Fraunhofer ISE in Freiburg, as well as ZSW in Ulm, all together into a joint project. And then we will do, with our expertise in basically development, we'll try to solve the problem together with industry. Nothing will happen without the impact and the close cooperation with industry. And again, we think that's the most important thing in the HyFab project, and maybe also one of the most important differentiators to other projects that are now mushrooming everywhere, dealing also with the development of fuel cells. So that also brings me a little bit to the summary, a little bit ahead of time, but it's maybe the right direction. So the HyFab is, as I have shown you, a joint project of ZSW, Fraunhofer ISE, and the VDMA, the Association of the Mechanical Engineers in Germany. It should support the ramp-up of fuel cell stack production. So we are really focusing on the fuel cell stack because anyway, that's the key component. It's the most expensive one, the most difficult one. We are not looking into balance of plant components. Of course, we need them to run our systems, but we have access to them, and both Fraunhofer ISE as well as ZSW are very experienced in running basically full-fledged test benches for fuel cells. But the focus is really the fuel cell stack. And there might be other centers coming up in Germany later on dealing with hydrogen technology, starting from generation, storage, fueling, and doing the system around, but we can really concentrate now on the fuel cell stack. Technology input from industry, using today's material and components to develop processes for tomorrow. I stressed this point already twice, but I would like to do it a third time. And I would like a little bit to take analogy to batteries. If you look into lithium-ion battery, what is an extremely successful technology today, and if you look back basically into the invention of the batteries and the Nobel Prizes being awarded, then you see the materials and the technology where the Nobel Prize was awarded was basically something that Sony brought into the market 30 years ago. And the lithium-ion battery has not changed much in view of materials being employed for the first 10 years. But what was done very successfully in the first 10 years was already a cost reduction and an increase in energy content. So basically using the materials that had been available at that time, for instance, the LCO cathode material from Good Enough, the industry was able to build a working system and to start getting the costs down also by ramping up basically the volume of batteries being produced. And only in the last 10 years, with basically lithium-ion batteries moving into automotive applications, then also on the material sides, development had been done, for instance, in changing from cobalt as a key element in the cathode to nickel and manganese right now, and now also on the anode side from graphite to silicon. But it underlines that you cannot do everything at a time, so let's focus on what is really necessary to do. And this is the ramp up of a fuel cell from lab and development into mass production using the components that we have. Therefore, also the HyFab project will concentrate on that one. We will focus on the assembly technology. Assembly also starts with the MEA development already in Freiburg, but then especially the assembly of the fuel cell stack, quality checks, manufacturing speed, reduced off-spec rates, and factory design. So sometimes I make the joke, we are building stacks with an error, with a mistake, to learn what is the impact of that later on in the use of the stack. We have the generic stack for industry training and to attract new players. We think we need more players in that market. We need more positive competition, and in automotive application, and this is where we see the fuel cells, at least you need 2 suppliers, even better having 3 of them. Therefore, more companies have to enter, and we want to be the door opener for these companies. And by doing that, we want to generate the industry know-how, we want to train experts, we want to train new players, and we want to train basically also the publicity and the public around that a fuel cell is something that really you will see in the future in the mass market. And I think that's for today. Thank you very much for your attention. Again, thank you very much for the people giving the money here. We have a high responsibility with the money, and we will use it the best way. We are believing in fuel cells, and we hope to make it happen. Thank you very much.
Yeah, thank you very much, Professor Dr. Markus Hölzle, for your very interesting presentation and for the insight in the HyFab Baden-Württemberg. Thumbs up that you have a lot of participation by the industry, of course. As you said, I think in the last year, especially, the fuel cell technology really gained momentum. We see it within our cluster network. A cluster fuel cell BW gained a lot new members in the last year. So the interest is very, very large by the companies. So we appreciate really the CCSW being such a valuable part of our network. So together, I think, we just go on working and working on the breakthrough of the fuel cell technology here in Baden-Württemberg. So thank you very much.